In this lesson, we will solve square root equations and cubic root equations. What we're going to start with is solving square root equations, and we're going to start with example number 1. Now remember, when you are asked to solve, it means you have to find the solution. You have to solve for x. So let's go ahead and copy our first example, and let's talk about it for a second. To be able to solve for x, it means you need to get x by itself. So first of all, you need to isolate the radical, and you do that by dividing both sides by 2. You get square root of x plus 1 equals 7. Now, then we move on to our next step, which is basically to apply the inverse operation to both sides. So, to get rid of the radical, I have to square both sides. So let's go ahead and do that. When you square the radical goes away. You end up having x plus 1 equals 7 squared, which is a 49. Now to solve for x, let me move that to the third column. Now to solve for x, you need to subtract both sides by 1. So x ends up being a 48. Now once you box your answer and you say that x equals 48, that's your solution. Remember to check for extraneous solutions. Plug that in the main equation. Now plug in the value 48 for x and check if that is going to give you a 14. 2 square root of 49, is that going to give me a 14? Now the square root of 49 is a 7. 2 times 7 is 14, so yes, that gave me 14. So x equals 48 is basically a solution. However, if I plug it in and it didn't give me what I'm expecting, then that would be an extraneous solution. This is how you solve square root equations. Now let's move on to number 2. So let's look at our equation, which is 15x plus 10 equals 2x plus 3. Now, is the radical isolated? Yes, it is. So my first step is already done for me. Now let me move on to my second step, which is basically to do the inverse operation. So what I need to do is I need to square both sides. So I square the radical to get rid of it, and think of 2x plus 3 inside the parentheses, and you're going to square that. Now, a common mistake that a lot of students do, they try to square the 2x alone and get 4x to the power 2, and then they square 3 alone and they get a 9, and they try to solve this equation. That is absolutely wrong. Remember, when you want to square the right side, you are squaring all of 2x plus 3. So to solve that, you need to write it out twice, and you need to FOIL it, okay? So on the left side, I have 15x plus 10. 2x plus 3 to the power 2 is 2x plus 3 written twice. FOIL that, you will get 4x to the power 2 plus 12x plus 9. Now I should have done a better job including all of that in one column. Oh well. Now to solve, let's move on to our third column. So you need to move everything to one side of the equation, set it equal to 0 so you can actually solve. How do you do that? Move the 15x to the other side and move 10 to the other side. So let's do that. So as you can see, I'm trying to, so 12x, move 15x by subtracting it from both sides, okay? And then we have a plus 9, and I'm going to subtract 10 from both sides. I end up having 4x to the power 2 plus, or minus basically, negative 3x minus 1 equals to 0. So I moved everything to one side of the equation, because if you take a closer look at this, you can, you can factor it. There are multiple ways to factor something like that. You can either use the grouping method or you can use big X. I'm going to use big X. To do that, you multiply a and c. So you have to think of two numbers that multiply to give you negative 4, that's your a and c, and add to give you b, which is negative 3. Now the two numbers are negative 4 and 1, because negative 4 times 1 is -4, and -4 plus 1 is -3. Now, once I find the two numbers, I have to divide by a. So -4 divided by 4, that's a -1. So x minus 1 is going to be my first factor. 1/4. So that's x plus 1/4. That's going to be my second factor. Remember, you have to do bottoms up. So that will end up being 4x plus 1. Now, if you want to double check your work, you can always FOIL those two factors, and you should end up having 4x to the power 2 minus 3x minus 1. Now, once I factored this quadratic equation, I can set each factor equal to 0, and I can solve for x. So my first solution, according to this, is x equals 1. And my second solution, if I set the second factor equal to 0, then my second root would be -1/4. So I have two solutions, as you can see. Now what I'm going to do is I'm going to plug that back into my main equation, each one of them, and I'm going to check if that's going to give me an extraneous solution, which means that if I plug it in, it will not work, or will it give me a correct solution. So let me copy. So we're doing now the fourth step. I'm going to write it over here. I have more space over here. So it's square root of 15x plus 10. Let me make sure I'm copying the correct equation. Yes, equals 2x plus 3. And what I will do now is I'm going to check my first factor, which is x equals 1, my first root. So plug in 1 for x, and let's see if it's going to give me something acceptable, something true. 15 times 1 is 15 plus 10, that's 25, and that's going to end up being a 5. Square root of 25 is a 5. Now 2 times 1 is a 2 plus 3, and that is going to give me a 5 as well. So yes, x equals 1 is a solution. Now I'm going to check x equals -1/4. So I'm going to plug it back into the main equation. So 15x plus 10 equals 2x plus 3. I'm going to plug in -1/4 into both sides of the equation, and let's see if this is going to end up being the same. Now 15 times -4, it's like 15 over 1, multiplying fractions. You multiply the top together, you get -15, and you multiply the bottom of the fraction together, you get a 4. Now plus 10. Okay, I'm going to do the left side first. Now in order to be able to add fractions, I have to make sure that they are of the same denominator. So to have a denominator of 4, I need to multiply the bottom and the top by 4. So 10 times 4 is a 40. Now to check my work, 40 divided by 4 is a 10, so I'm correct. And then -15. Now I can add those two fractions. -15 plus 40, that will give me a 25 over 4. Now, remember, this is inside the square root. So square root of this fraction, you can square root 25 and get a 5. And you can square root 4 and get a 2. So I got 5 over 2. Now let's check the other side of the equation. Is that going to give me 5 over 2 as well? So let's double check. When you multiply two fractions, remember, you'll multiply the top by the top and the bottom by the bottom. So -2/4 plus 3. You can actually simplify this to be -1/2, just to make things easier if you want to. So now I'm actually adding -1/2 plus 3. Let's put a question mark on the equal sign because I do not know if this is going to be the same. We're checking. So -1/2 plus 3. To be able to add those two fractions, I have to have the same denominator. So I need to multiply the bottom by 2 and the top by 2. 3 times 2 is a 6. And that's a -1/2. -1/2 plus 6 over 2. It is 5 over 2. So yes. So as you can see, I have two acceptable solutions. X equals -1/4 and x equals 1. Okay? So that is an acceptable solution, both of them. Now let's move on to our third example. And it's called half power equations because you have the half power. But like we learned in rational exponents, you can change that into a radical equation. So let's zoom in. And let's copy the equation and let's isolate the radical. Because as you know, you can change any rational exponent into a radical expression. Now to do that, you see how this is a radical minus a radical? So if you move this to the other side, then basically you're setting. So move that to the other side by adding it. So basically what you're doing is you have now x plus 6 to the half power on one side, and you have 2x minus 4 to the half power on the other side. And let's change both of these to radical expressions. So the top is going to be the power, the bottom is going to be the index. So I have basically a square root of x plus 6, it's a square root. And on the other side I also have a square root of 2x minus 4. So next time when I square this side and this side, both of the radicals will go away. That's why I had to move this to the other side, have radical on one side and a radical on the other side. So let's go ahead and apply the inverse operation, which is basically square both sides. Now once you square both sides, the radical goes away. So I end up having x plus 6 equals 2x minus 4. Now to solve this, I need to isolate or basically move all the x's to one side of the equation. So I'm going to subtract x from here and I will end up having 2x minus x is just an x. And I can add a 4 to the other side. So 6 plus 4 is a 10. So x equals 10 is going to be my first solution. Now remember, I have to plug it in and check. So I'm going to go back to my main equation. X plus 6 to the power half minus 2x minus 4 to the power half, and that should be equal to 0. Let me double check that I copied the correct equation. So let's plug in 10 plus 6 to the power half, so that's basically 16 to the power half. 16 to the power half means square root of 16, which is a 4. Now minus 2 times 10 is a 20 minus 4 to the power half, so that's basically 16 to the power half, which is again square root of 16 and minus 4, so that's equal to 0. So it worked. I checked and it worked, so x equals 10 is an acceptable solution. If I plug it in and it doesn't work, then that would be an extraneous solution. So this video covered how to solve square root equations and half power equations. Now let's move on. The next example is a half power equation as well, so let's go ahead and copy it. Now we have x minus 6 to the power half. That is equal to x minus 2. I can rewrite the power or the rational exponent into a radical expression. Now to isolate the radical, as you can see it is isolated. Now we need to get rid of the radical by squaring both sides. Now remember, x minus 2, think about it as a whole thing that's going to be squared, okay? You don't square x by itself and 2 by itself. So I end up having x minus 6. I end up having x minus 6 equals x minus 2 to the power 2. So basically you write it out twice and you FOIL. And I end up having x squared minus 4x plus 4. Now to solve, I need to move everything to one side of the equation. So I need to move the x over and I need to add the x. So x to the power 2 minus 5x plus 10. Now let's go ahead and try to factor this one. Okay, can you think, this should be a mental math problem since a is 1 and 1 times 10, which is the c, 1 times 10, that's a 10. So can you think of a number that multiplies to give you 10 and add to give you negative 5? I cannot think of a number, honestly. So this is not a problem I can use factoring to factor or solve. I have to think of the quadratic formula. And the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac, all of this over 2a. So a is 1, b is negative 5, and c is equal to 10. Now, if this works, then most likely I will have an irrational solution. So I will not have a rational solution since I was not able to factor it. I will have an irrational solution, which is still a real solution. Or if I end up having a negative under the radical, that would be an imaginary solution, and then I will have no real solutions. Let's see what will happen. So negative times the negative 5, which is the b, plus or minus square root of b squared. So if you square negative 5, you will get 25, minus 4 times the a times the c. All of this over 2a, which is 2 times 1. So negative times negative, that's a positive. Now negative 4 times 1 times 10, that's a negative 40. So 25 minus 40, that's a negative 15 over 2. Whoops, I have a negative under the radical, so that is imaginary number. So I can conclude that I do not have a real solution. I did not have a real rational solution because it was not factorable. I did not have a real irrational solution because I ended up having a negative under the radical. So I can say there are no real solutions. Now let's move on to our next example. Now this is a cubic root. So let's write down the cubic root. And as you can see, the cubic root of x minus 5 is equal to x plus 1. Now the radical is isolated. There's nothing being added or subtracted or multiplied by the radical to get rid of. Now to apply the inverse operation, it means I need to get rid of the radical. Now before with the square root function, I had to do what? I had to square both sides to get rid of the radical. But here, since the index is a 3, so to get rid of the cubic root, I have to cube both sides of the equation. Okay? So the cube and the cubic root will cancel each other. So I will end up having x minus 5 on one side of the equation. And again, you do not cube the x by itself and the 1 by itself. You think of x plus 1 as one factor, and you have to cube all of that. Now to do that, it means you have to write x plus 1 3 times, and you need to FOIL it. So let's go ahead and do that. I have x minus 5. Let's go ahead and FOIL the first one. X times x, that's an x squared. And then x times 1, that's an x. 1 times x, that's an x. And then 1 times 1, that's a 1. Now if you simplify that, that will end up being x squared plus 2x plus 1. And now you have to multiply it by the third x plus 1. So let's go ahead and do that. So x times x to the power 2, that's x to the power 3. And x times 2x, that's 2x squared. And then x times 1, that's an x. Now you have to multiply the 1 by the whole thing. So 1 times x squared is x squared. 1 times 2x is 2x. And 1 times 1 is a 1. Now let's combine like terms. X to the third is by itself. 2x squared and x squared, that's 3x squared. X and 2x, that's a 3x. And now I have the 1 by itself. Now let's move everything now to our third column. Now I have an x minus 5 on the left side of the equation. Since I cube root the radical, so the radical goes away, I end up having x minus 5. I cubed x plus 1, wrote it down 3 times, FOILed, and ended up having this, so I'm going to copy it. Now remember, every time you have multiple powers of an x, it means you have to actually move everything to one side of the equation, end up having a 0 on the other side. So you can factor that polynomial, let's say, and get different solutions. So to do that, I'm going to subtract x from both sides, add 5 to both sides. So I will end up having a 0 on the left side, x to the third, plus 3x to the second. Now 3x minus x, that's 2x. And plus 1 plus 5, that's going to be plus 6. Now that is a polynomial made up of 4 different terms. So let's go ahead and group the first two and the second two. Now, to be able to solve that, I have to check what's common between these two. X to the power 2 is in common. So if you factor x squared out of x cubed, you will end up with an x. If you factor x squared out of 3x squared, you will end up with a 3. Now 2x plus 6, what's common between them? That's the 2, that's the GCF. Now 2 times x is a 2x, and 2 times 3 is a 6. Now to check your work, you can always distribute the x squared, and you should get that. Distribute the 2, and you should also get that. Now as you can see, we have a common factor, which is the x plus 3. And those GCFs should be your second factor. So there you go. I just factored this polynomial. Now to find the solutions, you have to set each factor equal to 0. So that means that x is equal to -3. That's my first solution. Now let's set this one equal to 0. So to do that, I have to subtract 2 from both sides. So x squared equals -2. I have to square root both sides to get rid of the square. So x is equal plus or minus a -2 under the radical. So square root of -2. That's imaginary. So I can disregard this solution, and I can say that my only solution for this problem is x equals -3. Because I only need real solutions, okay? Which is basically the intersection between this graph and this graph, okay? Now to check, which is basically a real solution, not the imaginary one. So I'm going to copy this down into the last column, and I will plug in -3. I should end up having the same value on the left and the right side. So let me copy that. Let me see. Okay. So I have x minus 5, and I have x plus 1. Let me double check. Okay. Now let's plug that in. Now cubic root of a -3 and a -5. So if you plug in -3 for the x, you will end up having a -8 under the cubic root. Now cubic root of -8, think of a number when you multiply it by itself 3 times, you will get an 8. That's a 2. And remember that it's a -2 because -2 times -2 is a positive 4. And times -2, you will get a -8. So the answer of cubic root of -8 is a -2. Now let's see if we're going to get that on the right side of the equation. So plug in -3 for x. You will end up having a -2. So that is correct. So x equals -3 is an acceptable solution. This is how you would solve a cubic root. Now let's move on to our last example. 2 parentheses x minus 50 to the power 1/3 equals -10. Now to be able to solve this, I have to isolate the radical by dividing both sides by 2. So I end up having x minus 50 to the power 1/3 is equal to -5. Now change that into a radical expression if you feel more comfortable. But you can keep it in the rational exponent. It's the same way. Now to be able to solve this, I have to apply the inverse operation. Since I have a cubic root, I have to cube both sides. So raise both to the 3rd power. -5 to the power 3 means -5 times -5 times -5. That's a -125. When you cube a cubic root, they both cancel each other. You end up having x minus 50. Now add 50 to both sides. You end up having x equals -75. Now remember, you have to plug that back into the main equation and check if you're going to get an acceptable value, acceptable answer. I should have solved that in the third column. Okay. Now let's copy this into the last column. And let's see if we plug in -75 for x if we're going to get -10 on the other side. So let's double check. Let's put -75 for x. So you end up having -75 minus 50, that's a -125. Now, can you think of a number when you multiply it by itself 3 times, you get -125? Because you can think of this way. -125 is basically -5 to the power 3. And then you put 1/3 on the outside. Now let's put a question mark because we don't know if this is going to be correct. Now, power to a power, it means you need to multiply. So 3 times 1/3. This is a good review of all the rules that we've learned in the previous lesson. Now 3 times 1/3 is basically 1. So 2 times -5 is a -10. So that is absolutely correct. So yes, x equals -75 is an acceptable solution. Now this is the whole video for the whole lesson. Make sure that you work on the practice sheet to get extra practice.